Two inscribed equilateral triangles are as shown. Find the radius, r, of the semicircle. Label points E, C, and D. Also, label angle beta. From triangle OED. Line EC divided by sine beta equals to line ED divided by sine 120 degrees. Substitute other values and we have that 3 divided by sine beta equals 7 divided by sine 120 degrees. Cross multiply and we have that sine beta equals the product of 3 and the square root of 3, all divided by 7, after substituting values and simplifying them. We call equation 1. Join line O, C equals radius, R. From triangle EOC. Angle alpha equals 180 degrees, minus the sum of 120 degrees and beta, which equals to 60 degrees minus beta. It implies that angle OEC equals the sum of alpha and 60 degrees, which equals to 120 degrees minus beta. Using cosine rule, we have equation for the square of line OC as shown on the screen. We call it equation Y. Substitute values and we have that by trigonometric identity. Cosine 120 degrees minus beta equals the sum of negative cosine beta divided by 2 and the product of the square root of 3 and sine beta divided by 2 after substitution of values and simplification. Let us find the value of cosine beta using trigonometric identity. Thus, cosine beta equals the square root of 1 minus the square of sine beta. Substitute value of sine beta. It implies that cosine beta equals 13 divided by 14 after simplification of substituted values. Then, we substitute the value of cosine beta obtained earlier into the above equation of cosine 120 degrees minus beta. It implies that cosine 120 degrees minus beta equals negative 1 divided by 7. Substitute this value into equation Y. Thus, we obtained equation for the square of R as shown on the screen. Recall that line OC equals radius, R, of the semicircle. Thus, the square of R equals the sum of 9, 49, and 6 equals 64. Find the square root of the equation to give that R equals 8 units. Therefore, the required value of the semicircle is 8 units.